One. And we're live! Oh, what a week it's been. Hi, I'm Tim Van Milligan. You are watching the RockSim Go Live presentation. This is where we talk about your RockSim questions and try to answer them. It's been a week, let me tell you. The winds blew in here 2 days ago. Approximately 90 to 107 miles per hour, and it was blowing. And our front door, it broke our front door. It almost took it off the hinges. And I still have to fix it. It's kind of a temporary fix for right now, but I need to replace a screw, and the screw just snapped off. So we're gonna fix that. I was trying to fix it like right before this episode, and I can only get it temporarily fixed. So it's working a little bit better than it was this morning, but yeah, that's what's been going on my mind, and I feel out of breath because I was running in here trying to get set up for this. Okay, so if you're new here, we do have the chats going on, and in the chat, say hello. Say your name and where you're watching from. This is an audience participation, so I expect your feedback because it's your questions that I'm here to answer. We have some people already in the room, and we have one me Leon from Bangladesh. Woohoo! That's far way away. That's got to be it's got to be like 1:30 p.m. or 1:30 a.m. there. It's like really early. I hope you're not. He's probably watching this episode to put him asleep. We have Nicola from Poland, Johan de Sloper from the Netherlands, and Carlos from Marietta, Georgia. And Johan says, seeing the B4 Starship, the Booster 4 Starship booster, I think it has just finished the first cryogenic test, pressurized with liquid nitrogen on the orbital launch mount. Well, cool. Somebody else is doing some work today. That's awesome. Okay, if you're watching this on a replay, we do these every Friday at 2 p.m. Mountain Time, which is 4 p.m. on the East Coast. And let's see, we will be here on Christmas Eve. I will be myself. I'll probably be in the building alone. But I think on Christmas Eve, other people might be off work, and so maybe they have time to actually watch this. So I'm going to throw that out there. We're going to be here Christmas Eve. Doing this, talking about rocket stuff. Education never quits, right? Oh man, we have Cobra Seal from New Zealand. Man, we've got more people from outside the country than inside the country. What's going on? Johan says, I've been sanding fillets on my new V2. Hopefully that's one of the V2s that we sold you. If not, yeah, it's a V2 is a nice model. Let's turn on my computer here so you can see what I'm seeing on my computer. This is the Apogee website. It's apogeerockets.com. Let me come over here and hide some of this stuff, make my screen a little bit bigger because there's never enough room. Yeah, we are 1 week before Christmas. So yeah, you need to send these packages out like today to get it to people in other parts of the country. That's going to be priority, first class today. If it doesn't get out today, it's going to go out Monday, and it's probably not going to be there in time for Christmas. And we don't control the mail, so we'll ship it, but once it leaves our hands, we have no control over it, unfortunately. If you want to learn how to use RockSim, go to How To and Guides. Come down here to Software. There's a free trial right here. You can click on, and that's where you would go to get the free trial. I was updating this page this week. That was another thing that happened. I took off this video and it's still there. So that still needs to be updated. That's kind of why I was looking at it. You can purchase RockSim 10 here. You can find out, the general idea of what RockSim is and how it helps you design rockets there. There's frequently asked questions here. There's version history right here. We have not tested it on Windows 11. We've heard from people that it might not work. So it still works under Windows 10. And we have new programmers that are actually getting ready to look into that bug. If you would like to watch video tutorials that aren't live on YouTube, they're right here on YouTube video tutorials. If you want to watch our back issues of RockSim Live training, that's right here. Click on that, and that will take you to here. We are on episode number 48 today. We're closing in on the number 50. Woohoo! Johan says, no, Tim, it's the scratch built V2. Okay, that's cool. He ran it in RockSim, right? I had to draw it out myself, but I have RockSim 10 now, so I can also do simulations with fins with curved edges. And I did launch it in the visualizer. Awesome. We have the new visualizer. Maybe we'll get to the visualizer again today. Marcel popped up from Parker, Colorado. Awesome. I did have some questions that came in via email. This one came in this morning at 2:16 a.m. from Ravi. And he says, I made a scaled down model of a 3-stage Saturn rocket. I don't know if it's a Saturn V, but I'm assuming since it's 3-stage. I previously mentioned in the mail, sometimes the simulation, each stage flies in a different direction at the launch initiation, and the rocket doesn't show stages as assembled continuously. I have attached the design file this email. Could you please let me know what the problem is happening due to my design inputs, or some parameters need to be tweaked? Okay, so he was in RockSim Pro, so let me open RockSim Pro here. It's popping up down here. I'm waiting for it to come up. Okay, there it is, RockSim Pro. Escape to continue. There's RockSim Pro. Let me quit mail now so that you don't get any more of these stupid pop-ups showing up here. Okay, so then he sent me his file, and let me drag that on here and open it up. Okay, so this is what he's calling his 3-stage Saturn V, or Saturn. He doesn't call it a Saturn V, he just calls it a Saturn, which is fine. Okay, looking at the back, this is hard to tell, but there are two, it's a cluster of two in the back. Just kind of getting the lay of the land here. Okay, that's 2 stages. He's got his transition on his booster stage. And that's the upper stage. Okay, so normally I would probably put these transitions on the other part of the rocket, but we'll take a look at it. Okay, let's look at it in 2D. This thing is huge. Look at this, diameter 13.77 inches. That thing is huge. Let's go see all 3 stages again. Okay, so first of all, when you have a big diameter, a rocket, you can't see the center of pressure and the center of gravity symbols because they're really tiny. And those are stored with the design. So the size of those icons is what I'm talking about there. And that's right here, side view marker size. So if I come up here and I make these 1 inch in diameter and hit tab, you can see they grew a little bit, but still not big enough. Let's make it 3 inches. Okay, now we can see it. There's the center of gravity. There's the center of pressure. We have some mass objects in here. Okay, yeah, okay. Let's go look at the design components. So you're getting a synopsis of what I do when people send me designs. First, I try to get a lay of the land. What's going on? What am I looking at here? Okay, in booster 2, which is this one right here, he's got a 2-engine cluster. He's got a mass in there. Don't know what that mass is yet, but there's a mass. He's got a transition here. And then on the first stage, he's also got a cluster of motors in there. All right. Okay, so now I'm looking at it from the side view. Here's the top view. Okay, I zoomed in a little bit. So you got the 2 motors there, 2 motors there, 2 motors there. Let me take a look at this one right here. And I want to go back to the top view. Normally what I would do is look at this in 3D and just show the number of stages as one stage. And then look at it from the back end. No, I guess I can. I'm seeing through it, but normally a transition would be solid. Come on. There we go. So this is the normal view right here. And you can't see in the back. But if we do that, hey, I'm learning a new trick myself. That looks like a 3-engine cluster, right? Oh yeah, 1, 2, 3. So he's got 3 motors in there. All right. Okay, so that is kind of the rocket itself. Okay, so now let's go look at his simulations here. Oh, okay. Oh man, okay, so in this upper stage, he's got 2 motors called custom. No, that's the booster stage, because this must be the upper stage. He's got 3 L890s, 2 L's, so he's definitely doing high power, man. He wants this thing to go as high as possible. Okay. I would recommend usually starting out with a smaller rocket. This one is scaled down 1 to 97. Okay. All right, so I don't think I'm going to be able to run this simulation because he's got motors here called custom. Let's see if I can load engines. Okay, so when I click on it, it says I cannot be loaded because he's got custom motors here called custom, and he's the manufacturer. So he made them himself using Engine Edit, which is our software that comes bundled in RockSim. He's got a manufacturer HT. You got, I don't know what HT is either. So he's got some really different motors in here. So if I want to run this thing, I have to load normal engines in it. So I'm going to go up here to load engines, and I think the L890s are okay. All of these, he's got 75 millimeters in the upper stage, 98s, and then 132 millimeters in the boosters. So I'm going to load 98 millimeters in here. So let me choose an engine. So now I'm showing 98 millimeters, and let's see, I have no idea how big these motors are. I'm assuming he wants to use the biggest motors that we have. Here's an N2900. And let's just leave that alone. Just leave it plugged. I'll click OK. And then load all. So it loaded that motor into these 2 motor mounts as plugged. This one was 0. Okay. I would have them all at least the same. So let's plug that one. And then 132. I don't even think we have any 100. Ooh, we do. We've got an 25,000. And let's say plugged on that one too. So click there. So it loaded it there, and then we'll load all, and it loaded it there too as well. This thing is because it's got such big motors in it, it's going to take a long time to run these simulations because, because it's going to go really, really high. And the higher it goes, the more iterations it has to go through. So I might cancel it if it takes too long. So under staging, we have stage now. This is the booster stage. So I'm going to stage that one at usually I would say maximum ejection delay, but I don't have any delays in there. So I am going to make them both maximum ejection delay. Then go back here and make these have ejection delays. These 4 bottom motors, I'm going to choose them all as 0. And what this will do is it will allow me to use maximum ejection delay. Okay, so these are all max ejection delay, and then the upper stage is plugged, which means there's no parachute in it, so it's going to arc right over. Okay, so starting state, we'll probably have to give this one a longer launch rod. Let's make it 200 inches. Simulation controls, we'll leave that alone. Okay, let's choose a launch site. Let's choose Birmingham Boys. That's probably near Birmingham, Alabama. Wind table, 8 miles an hour. Let's change this. This is 20,000 feet. Let's make it 200,000 feet. We're going to have an 8 mile an hour wind. And let's go ahead and launch and cross our fingers and see what happens. Okay, so it didn't take off. Okay, so why did it not take off? Yeah, okay, so if it did not take off, now we got to figure that out. So let's start going through usually if it doesn't take off, there's something wrong in the design. I'm looking at the mass of the rocket, 1,247 kilos. It might be okay. Let's look at the parts list. Okay, so I'm looking at the parts list, and what I'm looking for is anything that looks out of the ordinary, like material-wise, and I'm also looking at the moment of inertia. He's got a nose cone, a body tube. What's his body tube made out of? Hollow wall thickness. Usually it will say the material. Okay, so I think it's the materials here. So let's go back here to the design components. Let's go to the nose cone. He's making this one out of carbon fiber, and it's hollow, and that's like really thin. Okay, I'll let that one go. This one here, made also out of carbon fiber. Okay, transition, carbon fiber, carbon fiber, carbon fiber, carbon fiber, carbon fiber. Make this a little bigger. Are there three centering rings in this Saturn design? Says Johan. And the answer is no. He just got no centering rings, but that shouldn't prevent it from not launching. I tried potassium nitrate, radium sugar, also kitty litter plug, but I think we concluded that the needle, yeah. Can't even see staging an O motor. Okay, so back to here. I was checking comments, making sure things are going. Okay, so the fin set looks okay. transition, carbon fiber. That's that transition there. Carbon fiber. Why is this not doing that? Carbon fiber. Looks okay. Carbon fiber. Okay. Carbon fiber. Okay. Okay. Thin sets. I'm checking the mass. Looks fine. Okay, so nothing out of the ordinary. All right, so if it still doesn't launch, this one said it didn't even leave the rod. That one crashed. Then we start deleting things. You can see that these motors are so big that they're hanging into the upper stage. So let's go to the design components. Now let's start by saving this design and do a save. Oops, I want to do a save as. I want to put it on my desktop. Desktop. Okay. Oops, let's give it a new name. .2. Okay, so now I can start modifying this and I leave the original one alone. So let's delete the booster stage. So I'm going to go to the Rocket Design Attributes. Oh, I want to go number of stages, make it 2 stage, and that's going to delete that bottom stage down here. Yes. Okay, and now let's try to launch it again. Still didn't launch. Okay, let's take the top, make it a 1-stage rocket. Yes. And let's launch this. Okay, so it launched now, so that tells me that there's something was in the 2nd stage. Look how high this thing is going. 7,500 feet. Wait a minute. Let's run that again. And it crashed. Why did it crash? Because it doesn't have any parachute in it. Run it again. Let me move this over so you can see some of this stuff. Maybe it's hidden here. I'm going to launch it again. Looking at the altitude. Okay. Okay, so man, this thing is like so heavy. It's not going very far with 3 L motors in it. So why is going on with that? I would think that should go a lot higher than 7,500 feet. So let's take this transition here and delete it. Yes. And let's see, does he got anything turned on? No mass overrides. That all looks fine. Okay, so we deleted the transition and let's launch it again. Oh, now it doesn't even leave the pad. What the heck is going on? Yeah, this is crazy. Let's go with the nose cone. Let's see here. Instead of being carbon fiber, let's call it fiberglass. Click OK, and then launch. Still didn't leave the pad. Okay, so it's probably not the nose cone. Let's try the body tube. Let's make it out of something that's different, just to see if it's the material. Let's call it G10 fiberglass. And let's click OK and launch that. Okay, so that one launched. only went 1,259 feet with 3 motors. That should go a lot higher than that, right? 19,000 grams. Let's unload the motors. Clear all. It's 6,661 grams. Okay, let's load them back in. So loaded it back in. Let's run that simulation. Wait a minute, let's double check it here. Starting state. We're going 5 degrees from vertical. That looks fine. Let's see the flight profile. See what that looks like. Still the same height, and it's loading the visualizer. Launch. Okay, look, it's unstable. That's why it's not going very high. This is why you need the flight visualizer. If you're just looking at the summary screen, you're missing out on the key piece of information. The rocket went unstable. Okay. All right, so yeah, okay, so the center of gravity is behind the center of pressure, which is with the problem. Johann the Sloper says unstable. He probably saw that about 5 minutes ago. Yeah. Check the mass objects. Let's check the mass objects. Okay, so why is it hanging up on me here? I think it's hanging up on me. This is what happens when you got so many windows going on at once. Let's go force quit. Roxim Pro not responding, force quit. Okay. Oh, well that's why I was hanging up, because the launch visualizer is still running. I didn't click the button. My fault. Any other questions while we're looking at this? Mark Sell says, looks like the middle stage motor extends into the upper stage. Yep, you are right, Mark. It was definitely doing that. It was open. It was on the desktop. What was that called? Saturn. Number 2. This is why we save things. Okay, so yeah, so basically he's unstable. When you try to push the limits of everything, you know, that's where things can go wrong. And he says check the mass objects. Let's look at those mass objects. 1,000 grams. And he's putting 1,000 grams at the base of the rocket. Why would you put 1,000 grams right here? That doesn't make sense. If you're going to put weight in and you unspecify it, you'd probably put it up in the nose cone to move that center of gravity forward. Okay, so I would assume that this rocket needs work. What he should be doing, and this happens a lot when people want to do really like super high projects that go really high. They just jump right in and put the biggest motor in without learning the software first. So I would say to Ravi, start smaller with smaller motors, learn stability, make your rocket stable, and yeah, that's why things are going crazy. That's when you are looking for problems. Overlook the simple things, right? Lead motor retainers, says Carlos. Yeah, he's got lead motor retainers on there. Carlos also sent me a email, and he was talking about in our last newsletter on our website. If you go to the home page and this one here, Rocketry Innovations from around the world. I did an article and it showed a Saturn V with fold-out fins. Okay, and there was three, I don't know if you can see this. There was three different designs, three different ways to fold out fins. The one coming out from the middle of the rocket, like this. See, they just pop right out. And then there was one here where it's kind of like a jackknife fold, where they come in from underneath, and so they would fold downwards. So they go into the tube. And then this is a picture of somebody folding them in, and you can see that they're folded down. And you can see right here there's a rubber band that would snap those open. I'm not a huge fan of this style, because as the rocket's going up and your fins, since they come up, you can't see my hand, since they come upwards like this, what could happen is the wind could actually tilt them back down. So I'm not a huge fan of that. I like this version better. And this is upside down, where instead of hinging at the front and flipping this way, they hinge at the back, and the front comes back like this. So then it's, let's say, they're stored up like this, and then they flip down. And so then they would flip out. And then the wind holds them down. So it doesn't take a big rubber band to get them out or to hold them out. You just get them out and let the wind take care of it. So that's that one here. So Carlos's question, let's see if I got other pictures. Here's another one with that same design. And here's another one with that same design, where they hinge here at the back, and this one would fold down along this tube so that he could stick it inside the transition stage on the Saturn V or the Saturn 1B. He's got a Saturn 1B right here. Carlos asked, can you do that in RockSim, where fins are hidden inside the rocket and then they pop out? And the answer, unfortunately, is no. We talked about this one a while back, and I can't remember who asked it. She was in California, and they were doing a TARC rocket, and they were doing drag brakes on their fins. So they were deploying something to cause drag and to slow the rocket down. Although in this case, you would just be deploying a fin, but RockSim doesn't deploy objects other than a parachute or streamer. So unfortunately, you couldn't do it. I did something similar. My daughter built a Saturn 1B, and it had 3 stages on it, and the fins did flip out like that. Let me see if I still have that RockSim file somewhere. Rocket designs. I'm looking here, Saturn 1B with escape tower. Let me do a search. And I am looking for Saturn 1B, looking for RockSim files. Probably not that one, probably not that one, not that, not that. See, I'm looking, right now it's looking in my applications, and I knew I wouldn't store it there. There's more to look. this stuff with Saturns in it? Unfortunately, no. But so what I did, let me open up one of those other ones. Ooh, here, Saturn, here we go. Okay, so I had 3 different designs. I had 2 upper stages, sustainer stage, and this might be in the whole rocket. Do I say no? Okay, so you can see what I did was I designed the rocket with the fins out. So this is, make it a 1 stage. And like this drawing, see they're hanging out in the air, and that is because they hinged from the back. So that's where they needed to be positioned on the rocket. So that's kind of why they're hanging out in the air. Oops, that's RockSim. I don't want RockSim, I don't want center. So that's why they're hanging there. So I was able to run this as a 2-stage rocket. Holy cow, look at this. I had the bottom stage was 4 C6s and 4 A10s, and then the upper stage was an A10-3 and a C11. Let's load those, load engines. 1 new motor mounts were found. See, it loaded it right there. So that A10 was actually in the upper stage. Let me look at this here. Here's my booster. Look how complex this thing is. So what I'm getting at is, in order to do this kind of thing, you have to do the rocket in the number of stages that you have. So if I have a 3-stage rocket like this, I need 3 designs. I need the first stage by itself, or the rocket by itself without these fins. And let me see if I can find that design. Allison's stuff. No, man, what did I do? Saturn. And I want RockSim designs. So here's RockSim designs. Saturn V 2-stage. This was a Saturn 1B. Apogee Saturn 1B. Scaled down. Okay, Saturn 1B, sustainer stage, 2 stages with, okay, so let me try this one. It's either that one or that one. Let me go back. I'm sorry about all this. I'm trying to show you how to do this. 3-stage. No. Okay, so here is the all-up configuration. And let's load engines. And see, this has no fins right here. So I would assume that if I launch this stage is going to go unstable, and that one will also go unstable. So let's launch it. So let's load these engines. Oh, I already did that. And okay, so all right, they're loaded. Flight events. Okay, stage 1, stage at max ejection delay. I better check that. So I got all these A10s in here somewhere. A10-3, C6-0. So I'm wondering when it's going to stage. Is it going to stage after the end of the C6 burn or the end of the A10? That's a good question. We'll find out. And then stage 2, maximum ejection delay, and stage 2, this one right here. Where's the number 2? There it is right there. Has a C11-0. And then the upper stage, doesn't matter. The capsule has a parachute, that's the P, and that is going to deploy, let's say never deploy, never deploy, never deploy. So nothing's going to deploy, everything's going to crash, but I just want to see what the flight looks like. So it's the 60-degree launch angle, or 60-inch launch rod, 5 degrees from vertical. And choose a launch site. Let's go back to that Birmingham Boys because I like that one. And it has an 8-mile-an-hour wind. So let's launch this, see what happens. Didn't leave the pad. It went a maximum of 2 feet. Let's run it in RockSim instead. Come on. This launch visualizer here, force that one to quit. Let's go RockSim. Okay, so I'm back to where I was. C11-0. This one right here. There's a central BT60 core tube. So that's not really a motor mount, so I don't need anything in there. Everything else is loaded. This time it's going to deploy the parachutes. Maximum ejection delay. Let's make it a 60-inch launch rod. This one's going, let's angle it just a little bit. Launch conditions. Okay, so let's look at the flight profile. I do expect this to go unstable. It went a maximum of 53 feet. So, yeah, right off the rod, it went unstable. That is not good. Let's take some weight out of this rocket, but let's take the motors out of the top stage. Clear. Clear. Okay. It shows it's stable. Launch it. Still going unstable. This should be stable. These are old files, and I don't know what's going on with my old files. I'm sure there's something going wrong, and it's probably because of this escape tower. We had problems in the past with this escape towers. So what I was trying to get at was, in order to run those simulations, you have to run each stage by it separately. So you run the booster stage, see how high that goes with all the stages on top, and then you run from the second stage up and then the third stage up to see if they're all stable. To get an accurate simulation though, that's a good question. Let me see if there's any other questions here. Cobra Seal says, hey Tim, I've retired my grappler rocket because it's had over 5 flights and I'm making new rockets. Okay, that's cool. Only 5 flights? Come on, you can do better than that. Mark Sell says, I have asked about grid fins before and I'm wondering if tube fins would be a good substitute for simulation purposes. The answer, Mark, is probably no. Grid fins behave a little bit differently. And we have no data on how grid fins behave, you know, what grid fins do to the center of pressure. You could try it, but I wouldn't have 100% confidence in it. Okay, run first stage to burnout. How do you set the next stage initial velocity? That's what I was trying to get at, Carlos, is you run it. Let me get a 3-stage design. And just a basic 3-stage design that I know is going to work. So let me go to Estes has, okay, Comanche 3. No, okay, so so here's the Comanche 3 and I just loaded those motors in there. I just want to run a simulation real quick just to make sure it's working. Launch. Okay, so why did that not go high? See, the same thing, and this one went 2,500 feet, and this one only 638. What is going on? Let's look at the flight profile and see what's going on. There's the rocket. That's like right off the pad it went sideways. Why did it go sideways right off the pad? Are we flying in soup or what? Let's see what my starting state is. 60 inches. Let me check the weight. 170 grams, all loaded. That's not that heavy. We should be getting a lot higher than. Let me check my wind here. 80 miles an hour. That was just like the other day when it was 80 miles an hour here in Colorado Springs. Let's make it 8 miles an hour. Flight profile, let's launch it this time. This is better. Like, these numbers are going much higher. 2,700 feet. Okay. Okay, so the rocket's taking off, going up, going up. All right, so that's good. That looks like a good flight. Nice 3-stage flight. Here's the booster 1 coming down, booster 2, and then the sustainer. And this is going to take a long time to come down. Okay, so let's cancel that. I want to delete all these other simulations and to do that, you just highlight them and go to simulation and hit delete, and it'll ask you if you want to delete them, and I'm going to say yes. So I only have one. Just this last one, and I'm going to save this one. I'm going to save it to my desktop. Comanche 3 desktop. Save. Okay, so now to answer Carlos's question, you really can't do what he wants. I know what he wants to do. What he wants to do is, okay, if I'm going to run each stage by itself. So the first time I run it, I'm going to run it with all 3 stages, but I want to stop the simulation right when this one burns out. And then I want to see where the rocket is right before this second stage starts burning. So let me see if I can do this in the launch visualizer. You could probably do it in Roxim Pro and the launch visualizer, but Roxim Pro, for some reason right now, it's not working. And it might be that design was too complex. So that's why I saved it. And I'm going to go to Roxim Launch Visualizer. And the URL for this is roxim.com. The Launch Visualizer, it only allows you to run simulations, so you can't design simulations or design rockets. And I'm going to log in. Okay, logging in. It's still loading. Let me quit some of these other things. That one's quit. To free up some memory. Quit. No. Anything else running that I can turn off? Adobe InDesign. Quit. Okay, so what I want to do is upload a new design. I'm going to browse on my desktop. That was the Comanche 3. Open. And I'm going to upload it to the server. So it uploaded it, and now it's going to draw it right here. So there's the Comanche 3. Okay, so now we're going to be launching from, let's choose a launch site. Let's see if we can go back to the Birmingham boys. I'm plugging the Birmingham boys today. They should be watching this. Okay, so it recentered the map to somewhere near Alabama, I'm sure. Let me zoom out so you can kind of get a perspective of where this is. Let me switch north to the north. There's a big city right here, so I'm assuming it's Birmingham. So this is on the northern edge of Birmingham. And there's a nice little field that they have here. So we're going to launch right there. That's a nice grassy spot. So I changed the launch location, and I said let's launch it a little bit to the north at, not that, let's go 5 degrees. Okay, the weather, we got steady wind at 8 miles an hour, which is fine. Okay, so we're now loading motors. So the bottom stage, choose engine. And that was, what was that, a D12, something like that, or D11? Okay, we'll make it a D12 0. Click OK, and then this stage, choose engine. And that was going to be a C6 0. Okay, I'm going to load all. Load all will load it into this one. Anything that has the same diameter, it's just going to load it into. So it loaded it in there. And I just need to change the delay. So the delay on this upper stage, let's make it 7-second delay. Okay. And then to launch, right down here is the launch button where the little arrow is pointing. So go ahead and launch. Simulate. Okay, so 2340 feet for this launch. And every Friday when I do this, I'm not getting my image, my visualizer. And I don't know why that's doing that. Let me clear my cache and run that again. Clear browsing data. Hopefully this is still going. Okay, select rocket design. See, I've already uploaded it. So now if I go to my database, and I go to user designs. Oh, I'm not logged in since I cleared my cache. Choose design. Here's the Comanche 3. Select it. Okay. Gotta choose my launch site again. Birmingham boys. Okay. 5 degrees. I'm doing this really quick right now just because we're running low on time. Nothing seems to be working today. Not the way I wanted it to, anyway. C6, 7, okay. Load all. Change that one to a 0 because that's a booster stage. And then this is going to be the D12 0. Okay, so the motors are loaded back in. Let's see if it's going to work this time. Yeah, it's working this time. I needed to clear my cache. Okay, so here's the rocket sitting on the pad out there in Birmingham, Alabama. So there's the rocket right there. Let's get a trajectory view. Okay, now we're going to launch it. So I want to watch here and see where that booster stage falls off. Right there. Pause it. Okay, so the booster stage has fallen off, and I need to find it. Okay, see this little tinge of blue right there? That is probably where it's staged. So I'm going to back this up. And I'm looking at this image right here, and I'm looking for my booster stage to reappear. Okay, so there it reappeared. Right there. So at this point, now if I come up here to my, oops, wrong one, to my data panel, okay, at time 1.655 seconds, I've got a longitude and a latitude and an altitude. And let me take, I'm going to take a screenshot of this. Okay, and then I need to find the velocity. Here's the velocity right there. Right there. So I'm going to go take another screenshot of this. Cancel. All right, so this is how you would do it. You would grab that information on the position of the rocket and its velocity, and then I would come back here to the launch site. Let me find those images here real quick. Let's be on my desktop. There's one of them. And here's the other one. Okay, so let me move this one down and this one up. Okay, so latitude, longitude, so I'll come over here. So looking over here, here's my longitude, minus 68.184, 551, 551. My latitude 33.58, 10. See, I'm looking at this number right here, 1022. And my launch altitude above ground level. So now I need that altitude. And let's see, where's the altitude above ground level? 249.153. 249.153. And now I need my speed, because I'm going to put my speed right here. So in RockSim Pro, you have a starting velocity, and that's the current speed of the rocket. And that was 171.825, what was the units? Miles per hour. Where did that go again? Velocity 171. 171.825 miles per hour. And then you could also do the roll orientation. Body azimuth. Let's see this roll angle right here, 0.22. So 0.2222. Oops. I'm missing a decimal. 0.22280. I'm missing a 2 again. 80. And that tells me my roll angle. And now if I launch it again, but this time I would undo the booster stage, clear selected, and then rerun the simulation. Simulate. And hopefully we're at, this is not the right screen. That's not the launch visualizer. There it goes. It took a second to load. First we got to find the rocket, right? And right now it should be, how high up in the air did we say it was going to be? 249 feet. So 249 feet from the launch pad is where the rocket is. So if I come over here and just hit the rocket button, there's my rocket. And if you look carefully, we are floating in the air. And at this point in time, the rocket is already moving pretty fast. So if I come over here to velocity, you see my air velocity is what I set it at, 172.75 miles per hour. So it's already starting there, and you can see it's just 2 stages down here. And then you would run it again and pause it right when this second stage drops off, and then reload in the next stage. So you could do it, Carlos, with the launch visualizer and with RockSim to do it. So what you would do is build your design as a 3-stage rocket with the fins on the bottom like normal, run that simulation or save that design and upload it to the visualizer. And then take that design, drop the booster stage off, put your second stage on, and then put the fins deployed on or out. Save that design, upload it to the visualizer, and then do the 3rd stage with the fins out and send that one to the visualizer. And then in the visualizer you can set the initial velocity and the orientation. And so it's a hard way of doing it, but it's the only way to do it, to get those simulations of how to deploy fins. You got to just kind of do it in stages, just keep adding them up, and that should do the trick. It's hard, but it can be done. And I probably confused you more watching this because I wasn't ready for the question. Okay. Let me see my questions over here. By the way, I put my rocket with boosters that separate in RockSim 10. I didn't dig into it deep, but there seems to be a principal mathematical errors in the simulation. Well, Johan, There might be, or you just have to work through the simulations like I was doing here. You have to step back and just kind of look at the big view and then kind of narrow in, try to isolate the issue. Motors are not in the second and third stage. Johan writes, I tried winds at different altitudes but didn't see it to work. I got a straight up and down launch. I assume you're talking about the launch visualizer, and it should be working because as far as I know it's not working. Do they run system backups on Friday afternoons? I think what they do is, they work all week, and then Fridays they send the main code up to the server with all the corrections that they've made during the week. They don't update it on the fly. They update it once a week, and it seems to be on Fridays right before they go home. And then I got to clear my cache. Carlos says, I knew you could do that. I never found the data button. The data button is in the launch visualizer, and it's right here. It's this button that looks like a calculator. You click on that, and it brings up the flight data. All right, that answers that question. Oh, what a week it's been. So thanks for coming. As you can see, I struggle through these things just like everybody else. But be persistent. You'll get it. You got to put your thinking cap on. This is science after all, and it's rocketry, so I guess you'd call it rocket science. Use the scientific procedure of step by step, isolate things one at a time, eliminate all the variables but one. And then, like I did at the beginning, if you're looking at like a really complex model, just start dropping stages and see if that fixes the problem so you can isolate where the issue might be. That's what I do. So that's what I would recommend that you do. So thank you again for coming. You guys are the reason that I'm here embarrassing myself. We will be back next Friday, which is Christmas Eve. So this will be a gift to you, my present. Not really. You are my gift. It's so good that you're here showing up. If I was doing this alone, it wouldn't be nearly as much fun. And I probably wouldn't look like being as embarrassed as I am. So I've got to go fix my door because it's still kind of like partially fixed. And we'll see you next week. And in 5, 4, 3, 2, 1, we're ending the stream. So go out and launch something.